Healthy soils are essential for achieving broader goals, such as net zero carbon emission, reversing biodiversity loss, and sustaining human health. But to fix our soils, we must first understand them. We need tools to identify quickly the land that is being degraded and needs our attention. Then policymakers can target those areas with policies to promote sustainable land management and farming practices. For this series, we are interviewing some of the leading scientists who are working to create these tools. They are part of the project funded by the European Union called AI for Soil Health. And as the name suggests, they are using artificial intelligence and a range of other cutting-edge innovation to lead the way towards understanding our soils. In this episode, we hear from Annett Wania, project manager at Planet. Welcome, Annett. We are curious to learn how can remote sensing change the way we understand soil today.
So first of all, the power of remote sensing basically is that it is able to image the Earth's surface continuously over time and space, spanning the entire globe basically. So we have a way to measure processes on the Earth continuously. We have different sensors that measure different parts of the electromagnetic spectrum, which in simple terms light, visible light, but also light parts of the spectrum which the eye cannot see, but which the sensors that we use can see. Let's take the example of vegetation. You can map it, measure it through optical sensors, for example, visible light, but not only. You can use microwave sensors to measure soil moisture, other sensors to measure also nutrients, for example. And what we do then in soil sciences basically is we go in the field, we collect data in point measurements, we take it to the lab, we analyze it, which is quite intensive in terms of efforts. We need to take these measurements. What remote sensing data allows us is to combine these two data sets in order to establish a relationship that we can then use. So, for example, we train a model to learn the relationship between the point data and the measured information in the satellite. And then we can use that to upscale that information to other areas in which we didn't collect point data. And through that, become much more efficient in measuring soil, monitoring it over time, and use that past data that we collected basically to build that knowledge over time for the future. So we can use it not directly to measure soil health, but indirectly through what we observe on the surface, which reflects overall soil health. It's a powerful tool that we can use to make more efficient monitoring and informed decisions relating to soil.
And what new technology are you working on regarding remote sensing of agricultural land and it can empower soil managers to make decisions?
To take, for example, my company, Planet Labs, we have built a satellite constellation that consists of very small CubeSats who are very easy to build, very fast to build in time also. And with approximately 140 to 200 satellites in space, we are able to image the Earth once per day. That provides a very dense information that you can build over time. There are other constellations who have started much earlier in time. We have the public missions Copernicus that we are also for the Sentinel missions that we are using also in the AI for Soil Health project. Other sensors, Landsat, that we are using, who are monitoring continuous surface, and we use that, as I said, to relate what we observe in space at typically 500 kilometers above the Earth to the processes that we have on the ground. And for example, through that, with these daily scans, we can build a cardiogram of the Earth. I find this very interesting. So you have daily information that gives you the heartbeat of a place on Earth. For example, vegetation, you can observe very nicely how it grows during the vegetation season. And you can analyze the different behaviors over time, compare different years, and through that derive information about what affects the vegetation health, for example. In addition, we are testing a new sensor in space that we launched last year. It's called Tanager. It's a hyperspectral sensor which covers a much broader range of the electromagnetic spectrum. So meaning we have a much bigger variety of what we can measure on Earth. And we use that also to test it for mapping soil properties, because with certain parts of the spectrum we can measure, for example, soil organic carbon, texture, nutrients. We are testing it also to see how such a sensor, which traditionally comes from airborne sensors that can cover only a limited area, to spaceborne, which can cover much larger areas again.
Yeah. Can you use the Dutch pilot site of AI for soil health to give us a case study on how you're putting this work into practice?
Yeah, so the Dutch pilot site, which is a farmers collective that exists in 350 years, that is managing a land of 1,200 hectares in the Netherlands. We are using here remote sensing data and the products and the information we derive from it about vegetation health, but also soil moisture, to inform decisions relating to the management practices. The users there, the farmers, together with the Dutch Water Board, have installed sensors to measure soil moisture. So again, they are very local, very specific for certain areas, and you can't install a sensor in each field. But we compare the soil moisture we derive from satellite-based observations with these point measurements to see how close we get to what is measured on the ground, and then use that to upscale it to all fields, to the entire area, to then help them take more informed decisions with respect to irrigation, for example. Or we use the vegetation-derived parameters, vegetation health, to also inform where are deficiencies or where we relate vegetation health, where we see a drop, a stress, for example. Try to explain that with soil moisture relating to irrigation aspects or nutrient type of aspects.
And what specific soil health indicators can be reliably and accurately measured using current satellite technology? And what are the limitations as well?
It's not so easy to say, I must say. Even after 3 years into the project, we can measure soil health indirectly always, so it's not something we can measure directly. It's a challenge. It keeps being a challenge also define what we define a healthy soil. What we can observe is changes through the objects that cover the soil. So again, vegetation as a typical example, cropland, and we can use that to explain changes that can be coming from the soil as such, but there can be other factors driving it beyond the soil, like water and air quality or climate. For example, what we can measure directly is soil erosion through optical data, for example, or we can measure what I said, changes in vegetation cover. That can be a fact driven by changes in soil health. But again, as I said, we cannot be certain that this is the only driving factor. Another indicator we are testing is ponding, so meaning water that remains on an agricultural field for a longer period due to a combination of rainfall and infiltration capacity of the soil. And the idea here is that if the period of ponding extends over time, so over the years, that's an indicator of soil compaction, which is overall negatively affecting soil health. So that's something we are testing. We are not certain this will work, but this is something we are testing in the project.
How are you then ensuring the accuracy and the validation of the satellite-derived soil health information? What methods are being used?
Yeah. So in the project, I think key is ground truth, the data we collect in the field. As I said in the very beginning, that's an established process, established technology also that's used. We're also in the project looking into how we can still innovate that technology, make it cheaper, more affordable also for farmers, and including farmers, to collect that information. We collect that information on the pilot sites to build a data set that we can use both ideally to train our models with which we establish the relationship with the satellite-based information, but also to validate this information. So we use the data sets collected in the pilots, but also other data sets that have been collected in the field. For example, there's a huge soil data set called Lucas that is continuously updated, collected at European level, and that we use also to train models.
How might remote sensing power predictive technologies to look at soil health changes in the future?
Yeah, so I think because remote sensing, over the years and since remote sensing has started in the late 70s, we have built an archive of satellite images that we can use to analyze processes in the past, which allow us to establish a relationship in order to then use that to predict the future based on scenarios that we define. And that, depending on the problem you are looking for, you can use to basically model and predict what would be the impact of a certain management practice, so to say, or a certain climate scenario on soil health. And you can do that spamming entire regions, globe, continents. So I think that is where remote sensing has a specific capability or adds in combination with other information. And also, I believe soil sciences are benefiting from remote sensing. It's not traditionally a data set that has been used for it, but I think we see more and more the technology being integrated. It's one of a key layer in the soil data cube we are building in the AF Soil Health project as one of the covariates to predict the relationship with soil health and other parameters.
And finally, what kind of information derived from satellite data is most valuable and practical for you?
I'm a geographer, so I'm interested in spatial patterns, and remote sensing data allows to look into spatial patterns and to predict spatial patterns in the future. Then I find vegetation dynamics key for many applications. It's an obvious object that is present at the surface, and it reflects also what's going on underneath in the ground.
Thank you so much. AI for Soil Health is funded by the European Union and has received funds from UK Research and Innovation under the UK government's Horizon Europe funding guarantee. For more information, visit aiforsoilhealth.eu. That is AI for as number soilhealth.eu.